ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Welcome. Myself Nandini S, working as a lecturer in Mechanical Engineering Program, SJ Government Polytechnic, Bengaluru, Department of Collegiate and Technical Education. This video is for Mechanical Engineering General Program students of third semester regarding the course Mechanical Measurements. The course code is 15ME33T. We are going to discuss Unit 1 Measuring Instruments. In our daily life, we come across many measuring instruments. To measure weight, for example, to measure rice in kgs, we use weighing balance or spring balance, digital weighing machine. To measure body temperature, what we use? We use clinical thermometers. To measure time, we use clocks. To measure speed, we use tachometers. And etc. We can see many instruments which come across in our daily life. And also, students would have used simple devices like a scale to measure the unknown length and to measure angle. They were using simple protractors. Okay, so these are all the simple instruments, measuring instruments we come across in our school day lives and everyday life. So in this video, we are going to discuss about mechanical measurements. So this course is about mechanical measurements. So being mechanical future mechanical engineers. So we need to know or we need to study about mechanical instruments, mechanical measurements. So after completion of your engineering or diploma, so you are going to work in industries, in research laboratories, etc., in educational institutions, etc. So there you people come across many mechanical measuring instruments. In industries, or they use instruments for quality checking, for designing purpose, for production, etc. Okay. First, what we mean by measurement? The definition of measurement says, so the measurement is the act or the result of a quantitative comparison between a predetermined standard and an unknown magnitude. So it is a comparison. Which type of comparison? It is a quantitative comparison. Quantitative comparison between a predetermined standard and an unknown magnitude. Okay. So here we can come across a small simple diagram which shows the measuring process. Okay, so this entire thing is nothing but the measuring process. For any type of measurement, we use a standard, right? We need to use a standard. We are going to measure unknown magnitude. The unknown magnitude may be a mass, time, length, velocity, acceleration, speed, strain, etc. Pressure, force, etc. Unknown magnitude. Unknown. Unknown means what? We don't know that um, quantity, unknown magnitude, unknown quantity. Okay, we don't know that amount. So that unknown magnitude will be compared with the standard. So after quantitative comparison between unknown magnitude and standard, so we get the result. For example, a simple example, let us take. I don't know, we need to measure unknown length of a line. We don't know the length of that line. So what we will do, we will take a simple plastic scale or a steel rule. Okay. So here the standard is the scale and the unknown magnitude is the length. Unknown magnitude is the unknown length of a line. So we are measuring length with the help of a standard called a scale here. Okay, we are comparing the unknown length of a line with the standard called scale. So after comparison, we get the result in centimeters or millimeter, in meters, like that. So the unknown length, standard, and the result. Okay, so that is nothing but the measurement. For example, take rice. Okay, we need to measure the rice, the quantity of a rice. We don't know how many kg it is. So what we do, the we place the rice on a weighing balance. So it shows the result like 10 kg, 20 kg. So the unknown magnitude is the mass here, mass or mass. Okay, mass. The standard we used is weighing balance. It may be a digital or it may be a pointer and scale device. Okay, so the result is what we get, that is 10 kg or 20 kg. So the standard shows the result. So we are comparing the unknown mass of a rice with the standard. The standard is the weighing balance here. And the result what we get is in kgs. Okay, for 10 kg, like that. So in the same manner, so we can measure unknown magnitudes of various parameters. Okay, like mass, length, time, velocity, speed, acceleration, etc. So this is the definition of measurement. It is a quantitative comparison between a predetermined standard and an unknown magnitude. Unknown, we don't know that. Okay. So next, requirement of measurement. So to do any measurement, we need mainly two requirements. See, the first one is the standard used for comparison must be accurately defined and accepted internationally. The standard. The standard used for comparison must be accurately defined and accepted internationally. See, here we have used predetermined. Okay, predetermined means it should be predefined, predetermined. For example, simple example, 1 centimeter is equal to 10 millimeter. So it is predefined. It is already said. We have to follow that. Okay. So internationally, you know that. So 1 centimeter is equal to 10 millimeter. It is worldwide. It is internationally accepted. So we cannot use 1 centimeter is equal to 11 millimeter or 9 millimeter, like that. So 1 centimeter is always 10 millimeter. It is predetermined or predefined. Okay. Always the standard should be predefined. and it should be accepted internationally. So that is the first requirement. And and the second requirement is the procedure and the instrument used for measurement must be provable. That is, must prove its ability to measure quantities more reliably. Reliable means what? ನಂಬಿಕೆ ಅಂತ ಹೇಳ್ತೀವಲ್ವಾ. ಸೊ ಯಾವುದಾದ್ರೂ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ನ ತಗೊಂಡು ಮೆಷರ್ಮೆಂಟ್ ಮಾಡಿದಾಗ ಆ ರಿಸಲ್ಟ್ ಏನು ಬರುತ್ತೆ ಆ ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ ಅದು ನಂಬೋ ಥರ ಇರಬೇಕು. ಈಗ ನಮಗೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು 5 ಸೆಂಟಿಮೀಟರ್ ಲೈನ್ ಡ್ರಾ ಮಾಡಿರ್ತೀವಿ ನಾವು, 5 ಸೆಂಟಿಮೀಟರ್ ಲೈನ್. ಸೊ ನೋಡಿದ ತಕ್ಷಣ ನಮಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ, ಸೊ ಇದು 5 ಸೆಂಟಿಮೀಟರ್ ಇದೆ ಅಂತ. ಸೊ ಅದು 10 ಸೆಂಟಿಮೀಟರೋ 8 ಸೆಂಟಿಮೀಟರೋ ತೋರಿಸಿದ್ರೆ, ಈಗ ನಾವು ಯಾವುದೋ ಒಂದು ಸ್ಕೇಲ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಮೆಷರ್ಮೆಂಟ್ ಮಾಡೋದಕ್ಕೆ, ಆ ಲೈನ್ ಲೆಂತ್ ಎಷ್ಟು ಇರುತ್ತೆ? 5 ಸೆಂಟಿಮೀಟರ್ ಇರುತ್ತೆ. ಸೊ ಮೆಷರ್ಮೆಂಟ್ ಮಾಡಿದಾಗ ಸೊ 7 ಸೆಂಟಿಮೀಟರೋ 8 ಸೆಂಟಿಮೀಟರೋ ಆ ಥರ ತೋರಿಸಿದಾಗ ಸೊ ನಾವು ಅದನ್ನು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಇಟ್ ಈಸ್ ನಾಟ್ ರಿಲಯಬಲ್. ಸೊ ವಾಟ್ ಎವರ್ ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ is providing the result, it is not reliable. We cannot accept that because it is not accurate. Okay. See, the procedure and the instrument used for measurement must be provable. So if we have scale, well, like okay, normal scale, everyone know. When we take the 1 year caliper, so what is the least count and how we need to take the measurement using 1 year caliper? It should be known to everyone. So that is the procedure. Okay, so that procedure should be known to everyone and the instrument should give the accurate results. It should be more reliable. Okay, so next, mechanical measurement. So this is important. So mechanical measurement. If measurements related to mechanical engineering, they are referred to as mechanical measurements. Okay? If the measurements are related to mechanical engineering, simple, they are referred to as mechanical measurements. Example, pressure measurement, force, torque, strain, etc. Strain measurements, etc. Okay. ಸೊ ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ರೆ ನೀವು ಯಾವ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಮಾಡ್ತೀರಾ, ಯಾವ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಮಾಡ್ತೀರಾ ಅದು ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ರೆ, ಅದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿದ್ರೆ ಸೊ ಅದನ್ನು ಮೆಕ್ಯಾನಿಕಲ್ ಮೆಷರ್ಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆಕ್ಸ್ಟ್, ಮೆಥಡ್ಸ್ ಆಫ್ measurements. So mainly we have two methods of measurements. That is, first one, comparison, direct comparison, and the second one is indirect comparison. So before going to direct comparison method of measurement, we need to know the standard in detail. I have given the simple example while explaining the mechanical measurements and the definition of the measurement. Okay, standard means we have taken say example as a simple scale, simple protractor, weighing machine, clinical thermometer, clock, like that. So in engineering field, what exactly this standard is? See, something that is set up and established by an authority as a rule for the measure of quantity, weight, extent, value or quality. Something that is set up and established by an authority as a rule, okay, for the measure of quantity. So some authority will be there, some government authority. So that authority will set up and establish a rule. So they will give a rule. So this is the instrument. So everyone internationally should be followed this instrument for measurement of for measuring meters, and this is the procedure. Everyone should follow that. So like that. See, for example, a meter is a standard established by an international organization for the measure of length. So the standard is to measure length. To measure length, the standard is the meter. Okay. So meter is the standard. So like that. Mainly we have four types of standards. First one, primary standard, secondary standard, tertiary standard, working standard. Four types. So this primary standards or master standards. Okay, primary standards or master standards. Primary standards or master standards, and these standards are preserved under controlled conditions. Okay, so they preserve in national physical laboratories under controlled environmental conditions. So these are master standards, and this is one piece. You can have this, you can find this standard in some national physical laboratories only. Okay, so next, so see, and these primary standards are taken as reference standards for secondary standards, and these secondary standards are taken reference standards means to check the tertiary standards. Secondary standards are used as the reference standards, and the fourth standard is working standard. So these see, primary standards are master standards, right? Secondary standards are also um, secondary standards are also distributed to some places. Okay, so the primary standards you can find in only one lab, and these secondary standards are distributed for few laboratories. Okay, so like that. And tertiary standards, and these are found in laboratories and workshops, and working standards. So what we use in laboratories and workshops in educational institutions. Okay. So see, this is the primary standard, international prototype meter, and it is made up of metal. Okay, so that's why it is also known as material standard. Okay, it is preserved under good environmental conditions. Means its measurement should not change. 1 meter is equal to 100 centimeter, like that. It should be very accurate. Okay. So let us move on to direct comparison. As the name itself says, direct comparison. See, it is very simple. So in this method, measurement is made directly by comparing an unknown magnitude with this primary or secondary standard. It's a direct comparison. It's a direct comparison between unknown magnitude and the standard. It may be primary or secondary standards. Okay. So it involves this direct comparison method involves no mathematical calculations. No mathematical calculations. We just compare the unknown magnitude with the standard. So the next point is it is not always the accurate or best method. It is not always the accurate because here the human sensing plays a vital role. Okay. The direct comparison depends upon the human sensing. If He takes measurement accurately, so it will give accurate results. If he has some mental or physical conditions is not good, okay, if he has some problems, he may not take correctly like that. Okay, so it is not always the accurate or best method to follow. Next, indirect comparison. The measurement is made by comparing an unknown magnitude with a standard through the use of calibrated system. Comparing an unknown magnitude with a standard through the use of calibrated system. Indirect. We cannot get the direct results here in this method. So here we use the entire calibrated system to take the measurement. So the calibrated system may consist of sensor or transducer, signal conditioning unit and display unit. Okay. So it is more reliable and accurate method. So this comparison in this method, so we can get accurate results because here the entire system, the measuring system will take care of the measurement. The human sensing will be less here as compared to the direct comparison method. And a simple example, and if we use calibrated system, it is okay. For example, we need to measure the density of a density of a gas or a density of a fluid you take. It may be gas or liquid. So what is density? Density is given by the ratio of mass per volume. If we know the mass, if we know the mass already, mass of the fluid already, if we measure dimensions, that is for volume, mass into length into height, like that. If we measure the volume, so by mass and volume. So density is the mass per volume. So when we apply those parameters, so we get the density result. So here we need to use some mathematical calculations also. Okay. So this is about indirect comparison and it is more accurate and reliable. So see, when we take the difference, when we compare the difference between the direct and indirect comparison. The direct comparison in this unknown quantity is measured comparing directly with primary or secondary standards. So, as I told you, primary or secondary standards are master standards. Primary standard is a master standard. Okay, it will have accurate measurement. The standard will be very precise, very accurate, very accurate because it is maintained under controlled conditions, environmental conditions. Okay, so the measurement of that standard won't change. So direct comparison means comparison between the unknown magnitude and the primary or secondary standards. Secondary standard is also same like primary standard. It will be also accurate, but these secondary standards will be distributed for many places. Many or we can say some few places. Okay. But the primary standard is maintained in the single place, that is in national physical laboratories. So coming to indirect comparison, unknown magnitude is measured by comparing with a standard indirectly through the use of a calibrated system. Here we use entire measurement system. We have many components in this calibrated system. Okay. Direct comparison. Human sensors are very much necessary for measurement. Yes, it is very important. The the person who is taking the measurements, he should be very active. Okay, so that's why the human sensors are very much necessary for measurement. He should know the entire procedure, how to take the measurement. He should know about the instrument. Okay, so like that. So next, it consists of a chain of devices which form a measuring system. Yes, it consists of many devices, as I told you, sensor or transducer, or and signal conditioning unit, display unit, like that. Many chain of devices will be there. In direct comparison, results obtained from direct comparison are not that dependable. Okay, results obtained from direct comparison are not that dependable. See, this consists of a detector element to detect a transducer to transduce, that is transduce, and a unit to indicate or record the processed signal. So in the here we have some feedback element like that. Okay, so it will sense the input, it will transduce. Transducing means if there is some amplification is there, it will amplify that. So finally it will indicate the result. Okay, so like this. So next, direct comparison, not always accurate. It is not accurate always. Not always. Sometimes it may be, but not always. And in indirect comparison, it is fairly accurate. So this is about measurement, requirement of measurement, mechanical measurement, methods of measurement, standard, types of standards. Actually, there's a standard and types of standards are not in your syllabus. So this is I explained, this is only for your knowledge point of view. Okay, this is direct comparison, indirect comparison we'll study, and difference. Okay, thank you.